Hello, welcome to Supply Chain Management. In this session, we are going to look at a special class of inventory model which is called the single period inventory model. What I will do is, I will very briefly describe the context behind the use of this model. And then we will look at an example, we will use that example to learn about this model. We will pose the problem using that example. And then we will look at two different ways of solving that problem. One, the first way that we use to solve the problem is what we call the numerical method or the numerical solution, which we will talk about or discuss in this module. And thereafter, in the next module, we will also look at another method of solving the same problem, which is an analytical method for the solution. Okay, so this is broadly the agenda for this session. So let us begin first by looking at the context. The context is that this model is applicable to items that are perishable. Perishability means that the demand for that item exists only for a certain period of time. Okay, so demand lasts for a limited period. There are multiple examples of perishable items, and we will get into some of these examples as we move along. Second is that the demand for this item during that period, when the demand happens, that demand is probabilistic. What it means is that the demand is a random variable. We may have an idea about the probability distribution of the demand, okay, and this distribution we can know or decide by looking at historical data. Okay, so we know the demand in the sense that we know the probability distribution of the demand during that period, but it is probabilistic. Okay, now comes the real problem. The problem is that the lead time for procuring the item or for making or producing that item is so long that it far exceeds the period for which the demand is going to exist. Okay, so let me very briefly draw qualitatively. What I am trying to say is that if this is the period for which the demand exists, the lead time, so this is the demand period and this is the lead time for procuring or producing the item, and as you can see that the latter is far, far greater than the period for which the demand exists. And therefore, the problem is that we must order whatever item that we need to order from the supplier. We must order much in advance with respect to the period when the demand is going to happen. Once the demand period starts and we want to modify our order, it is not possible to do that, because even if we modify that order, the modified order will reach us much later, much after the demand period has already ended. Okay, so that is the issue. So what are the possible implications? Not very happy outcomes. For example, if your order quantity is less than the final demand, remember the final demand you don't know, But after the demand period, obviously there is one value of that demand that has happened. Okay, so if the order quantity is less than that demand, then you lose out on the opportunity of making profit for that excess number of units, which is equal to D minus Q. So you fall short by a quantity D minus Q because Q is less than D. Okay, and therefore, like I said, you could have made profit on that, D minus Q quantity, but unfortunately, you are not able to do that. The flip side, on the other hand, is that if the order quantity Q is greater than D, and remember D has only one value, okay? So if the order quantity is greater than D, then after the demand period is over, you are left with excess inventory, and this excess inventory is of no value to you because the item is perishable, which means that the demand no longer exists after the demand period, and therefore you may have to throw away those excess units, and again you lose. And what do you lose? You lose the money that you would have invested in buying or making those excess units, and that excess quantity this time is Q minus D, okay, because Q is greater than D. So this is the crux of the context within which we will discuss the single period inventory model. Okay, so moving ahead, I had said that we will introduce the problem and our discussion with the help of an example. So here we are, the example, NFL replica jersey. NFL, or the National Football League, is a major, big sporting event in the United States of America, where a number of different teams compete with each other, and these teams have a huge fan following. Okay, so Reebok has the sole rights to sell NFL replica football jersey. Now, what are these replica football jersey? These are almost identical to the actual jerseys that would be worn by the players who are going to play in this contest or tournament. And because they have huge fan following, there is a perfect market opportunity of making replica jerseys and selling them to the fans. Okay, so Reebok, we are told, has got the sole rights of making or whatever selling the NFL replica football jerseys. Now remember, each jersey will have a unique name and a number printed on the back. Okay, for example, here we have the jersey number 86. This is the front of the jersey, and as you can see at the back, this belongs to a player called Ward. Okay, so each jersey has got that, and therefore each jersey is unique. It's a different SKU for us. The peak demand lasts for about 8 weeks. So that is the period for which the demand lasts. And along with that, we are told that there is a contract manufacturer. Reebok doesn't manufacture the jerseys. It procures, it has subcontracted the manufacturing to a third party. And, the response time there is going to be between 12 and 16 weeks, which means that once there is an order issued by Reebok for a certain jersey of a certain quantity, it would take close to about 15 weeks for the jersey to be delivered to Reebok. Okay, which of course is much longer than the 8-week period for which the peak demand lasts, and therefore you can see the futility of ordering once the demand period has already started, because you'll receive it much after the demand has ended. Okay, so therefore, what is the key issue? The key issue is that Reebok must commit to order quantities in advance while the demand is uncertain. So you have to commit to a quantity that you are going to order, but you know that the demand is uncertain. So the question we are asking is that how does Reebok decide how many jerseys to order of each kind? Okay, so that is the problem that we will try to answer during the session. Okay, we are given some data. The data involves, we are told that the unit cost of a jersey is $10.9 and the selling price of each jersey is $24. Now please remember that these are representative unit figures, because there are different let's say sizes of jerseys. So the price and cost might differ from SKU to SKU, but we are taking one representative jersey for which we can assume the unit cost and price to be these values. We are also given the demand, and like I said that we don't know the demand perfectly, but we know the distribution of the demand, and this distribution happens to be a normal distribution with a mean of 32,000 jerseys and a standard deviation of 11,000 jerseys. Okay. Now, like I said, this demand is forecasted using historical data. So we are not going to bother about how this demand distribution was calculated or determined, but we will take this as given for our problem. Okay, so with this data, now let us think a bit about this problem, which is that suppose I order a quantity Q. Okay, so let me write this down. I order a quantity Q. Now there are two possible cases. And what are these possible cases? One is that the Q is greater than D, or Q is less than D. These are the only two possible cases. We are not considering the case Q equal to D, because that is, when the demand is continuously distributed with those kind of means and standard deviation, to get a quantity ordered exactly equal to the demand, the probability of that is almost zero. Okay, so we are not considering that case. Okay, now let me talk about the revenue that Reebok stands to make in this case. The revenue, of course, is going to be the price P. So let us call the price as P. P is $24 in our example. So the price P multiplied by the quantity sold. Okay. Now what is the quantity sold? If Q is greater than D, then the quantity sold, of course, is going to be D. You can't sell more than the demand, even though you have quantity, you have inventory which is more than the demand, but the maximum you can sell is the demand. So therefore, the revenue in this case is going to be P times D. Okay. On the other hand, if Q is less than D, then you can only sell Q, because that is the quantity that you have. The demand is greater than Q. You could have sold more than Q, but you have only Q, and therefore you sell only Q, and your revenue is P times Q. Okay, so we have two scenarios. The revenue could be P times D, or the revenue could be P times Q. However, if we were to generalize from here, then we see that the revenue can be written as P times one quantity, and that quantity can very easily be written as the minimum of D comma Q. I hope this is understood, that the revenue will always be equal to P times the price, unit price, multiplied by the minimum of D or Q. If D is less than Q, then you are able to sell only D. If Q is less than D, then you are able to sell only Q. So, so this is what it is. So here we are saying that the profit that Reebok ends up making is price P multiplied by the minimum of X comma Q. We are calling the demand here X because X is a random variable which the demand is. So we are saying minimum of demand comma order quantity. Okay, so this is the revenue. The second term that you see here, minus C times Q. Now this term is going to be our total cost because C is the unit cost, okay, and Q is the order quantity, and this total cost, C times Q, is going to be independent of the demand. It is going to depend only on the order quantity Q. Okay, so very, very simple actually. We have profit is equal to P times minimum of demand or quantity ordered minus the total cost, which is equal to unit cost multiplied by the quantity ordered. Okay, so given this understanding of profit, we are going to calculate or estimate the optimal quantity that we must order. And how do we do that? So I'm going to use a method for determining the optimal order quantity. Let me first very briefly describe to you the method. Okay, so this is the numerical solution method. What we do is, we have a normal distribution. Okay, the demand is normally distributed. So let me just quickly explain this. So let's say this is the demand. Okay. Now, remember, this demand is continuous. The normal distribution is a continuous distribution. Therefore, the variable involved is also a continuous variable. The variable X, which is the demand, is a continuous demand. But what we do is we discretize first. We discretize this continuous demand. How do we do that? Well, in a normal distribution, suppose I want to find out the demand at this point. Okay, remember this is, I want to find out the probability of the demand at this value. Remember, the demand is increasing in that direction, plotted along the horizontal axis. This gives us the probability of the demand. Okay, so if I want to find out the probability of this demand, what I will do is, I will take a segment and calculate the cumulative probability, okay, till this point. Because it's a normal distribution, we are very easily able to do that, find out the cumulative probability, and then I will find out the cumulative probability. So I find out the cumulative probability at X, and I find out the cumulative probability at X plus delta X. Okay, so this cumulative probability till X plus delta X will be slightly greater than the cumulative probability till X, and the difference will be the area of this strip, which I am just shading, this strip here, and this difference will be kind of representing the single probability of that value of demand. I know it's an approximation, but it's a good enough approximation that works in this case. Okay, so we are going to first discretize the normally distributed demand into a range of discrete demands. Okay, and of course, for these discrete demands, we also have the probability of each of these demands using the method that I just explained. Okay, then what we do is we consider a range of order quantity Q, okay, possible values of Q. And then for each value of Q, we have a set of demand. Remember, the demand is independent of Q. For each value of Q, I have a set of demand and the probability. So I calculate the profit for that Q under each demand scenario. So I have a set of calculated profit figure. And I do this calculated profit figure for multiple values of Q. And then at the bottom, I find out what we call the expected profit for that Q. So we have expected profit for various values of Q. And of course, the Q which gives us the maximum expected profit is the quantity that we choose to order, or what we call the optimal order quantity. It sounds maybe a little confusing right now, but I will solve the NFL replica jersey problem using exactly this method, and we will use Excel as a spreadsheet to help us. And once you go through that, I'm sure you will find it fairly simple. So here we go ahead with the solution. Okay, what you see on the screen, of course, it's a big bird's eye view of the space that we are going to use. The reason I'm giving you this bird's eye view is because I want to explain to you certain things before we commence our solution. And once we start our solution, I will give you a much more enlarged view of the cells wherever we are putting any formulae. So here we are, at the top left corner, we have simply written the mean and standard deviation of our demand, 32,000 and 11,000. At the same time, you can see here we have given the price and the cost of each jersey. Now, we have a column here which we are calling as demand, and this column is where we will put our discrete values of demand. And then alongside that, I also have a column called the probability of that demand. Okay, I also have a column here which is the cumulative probability. As you can see here, we will use the cumulative probability and the difference to determine the probability. And finally, we have the order, the Q values, discrete Q values listed along the row 4, as you can see, the one that I have highlighted. Okay, so this is just to give you an idea. Excuse me. This is just to give you an idea about the overall spreadsheet space that we are going to use. Now, let me expand this so that okay, much better. So we are going to now write our demands. Now, because we are going to consider a range of demand, now one can always say that, the minimum demand can be 0. And what about the maximum demand? Well, the maximum demand can be anything. you know, close to infinity? Well, very frankly speaking, theoretically maybe, but we can find out the upper bound on the demand, which means that we can have an estimate of the maximum possible demand. And how are we going to do that? Well, we are going to use our normal distribution. Remember, the demand is normally distributed. And what we know is that this is the mean value, and the maximum value of demand, we could take a cut here with this length, this length equal to 3 sigma. Okay, so demand mean plus 3 sigma is going to give me a kind of an upper bound, and we know that anything lying to the right has a very, very low probability, and therefore the actual demand exceeding this value of demand, the actual demand exceeding this value of demand, the probability of that is very small. And therefore, for all practical purposes, we will say that the maximum possible demand is mu plus 3 sigma. In our case, the mu happens to be 32,000 and sigma happens to be 11,000. So 3 times 11 is 33. 32 plus 33 is 65,000. Maximum we can stretch it till 70,000. Okay, so the range I'm going to put therefore is going to be, so the first demand that I put here is 2,000. Okay, then I will take 4,000 to take discrete ranges of 2,000 quantity. Okay, then I will take 6,000 and so on. So I am going to now drag this down, and yeah, is it happening? Yeah. So we go till a value of, let us say, 70,000. So there we are. The maximum demand that we have taken in our case is 70,000. Okay, fair enough. Now I come to the cumulative probability column, and the cumulative probability, there is an inbuilt function in Excel which gives me the cumulative probability, which is called NORMS. I'm sorry, not S, MDIST. So normdist. So as you can see here, this is normdist. So I choose this. My first argument for normdist is the value of X, which is here. Okay. My next argument is the mean of the demand, which is given here. The third argument is the standard deviation. And the fourth argument is called cumulative. Now, cumulative argument can be either 0 or 1. 0 means I don't want cumulative probability area. 1 means yes, I want cumulative area. So we will put 1 here because we do want the cumulative probability. And good. So this is what is going to give us. So let me just show you. The moment I press enter, I get a value of 0.0032. Now let me just come back to the formula. And the reason I want to come back is because I am going to drag this formula down across the range of demand that we have. And therefore, I want to freeze certain cells before we do that. And the cells, of course, that we want to freeze are B1 and B2, which represent the mean and standard deviation values. So I want to freeze them at 1. So I put a $1 and a $2. Okay, so I hope this is clear. Here I press enter, and then of course I copy this down. And interestingly, what I get is I get a cumulative probability of the demand being less than or equal to 70,000 as equal to 0.9997. So which is as close to 1 as you can possibly get. So it is fine, because we did say that there is a probability of the demand exceeding the 70,000 mark, and that probability is 0.0003 in our case. And like I said, this probability is very, very low. What do we do next? Very simple. I do the discretization of the cumulative probability. So I make this equal to the first value. Okay, so this is like saying the demand 2000 is actually covering the range 0 to 2000, and therefore we are saying that there is a probability 0.0032 of this happening. The next probability is the range 2000 to 4000. Okay, and that cumulative till 4000 is 0.055, and I subtract cumulative till 2000, I subtract that value, and the difference that I get, in our case 0.0023, this difference gives me approximately the probability that the demand is equal to 4000. Well, not exactly. It gives me the probability of the demand being lying between 2000 and 4000, which we are approximating as the probability of the demand being 4000. Good. So all I need now is to again drag this down, and we get the unit probabilities under the probability column. So far good. Now we have the demand values, we have our respective corresponding probabilities. Now comes our profit calculation for any combination of demand and the order quantity. So before I move on, please note that the first order quantity that I have taken here is 20,000 units. Now, one could have always argued that what if the demand is less than 20,000 units? Well, there is a probability of the demand being less than 20,000 units, but that probability is not too high. Please remember that our mean demand, the mean demand is 32,000 and the standard deviation is 11,000. So if I go one standard deviation to the left, 32 minus 11, I get approximately 21,000, and so I am kind of starting with this value of 20,000. Okay. Now please note that after I start from 20,000, I keep incrementing the quantity value by 1,000 and keep increasing the order quantity. Okay, so let us understand what we are trying to do here. So we are saying, let's take the first order quantity and let's consider the first possible value of demand. So with this demand and order quantity combination, I must get a profit figure here. Okay, so I'm going to calculate the profit figure. How do we do that? We have seen that the profit is equal to the revenue minus the cost. The revenue is price multiplied by minimum of what? Minimum of the demand or the order quantity. So that is my revenue minus my cost, but the cost is going to be unit cost multiplied by the quantity ordered, because the moment you order 20,000, you have committed to 20,000, you have to pay for 20,000, so that is your total cost. And there we are, we get a profit figure of minus $170,000. Now, because I am going to I'm going to kind of copy this throughout the space available for each of the demand values and each of the order quantity values. I'm going to put some dollar signs in our formula. So let us look at D3. Now D3 is our price. Okay, I want to freeze price completely. So I will put $D$3. Okay. Similarly, D4 is our cost. Oh, I'm so sorry. Not D4. I'm sorry. F3. Okay. F3 is our cost, and I'm going to put $F$3. And the reason I'm completely freezing these two cells is because I'm going to drag this down as well as I'm going to drag this across. So my price and cost values must be frozen. Fair enough. Now what about B6? Remember we have a B6. Let me just do this. So we have a B6 value here. Now in B6 we have the demand, and as we go down, I want the demand to change. Okay, so B6 must become B7 and then B8 and B9 and so on. But as I drag the formula across, the B must not change, which means the demand column has to be protected. So for column protection, I give a dollar sign before B, but no dollar sign before 6. Good. Now finally we are coming to D4. D4 is our order quantity. Now here please note that I want to protect, as I drag, my D must change. My D must become E and then F and so on, but my 4 must remain constant, okay, or remain as it is. So I have put a $4. Similarly, there is a D4 here. I will introduce a dollar sign here as well, and that about kind of does it for us. We have put the dollar signs appropriately so that we can copy this formula both vertically down as well as horizontally across. Okay, so I'm going to press enter here. So let's take this. Before we do that, I want to freeze panes perhaps. Okay. Now please note that I have quantity ranging from 20,000, 21, 22 and so on, and I'm going till about 39,000. Okay. Now one can always say, why not beyond 39,000? You can go beyond 39,000 as well. But what I'm doing is basically I'm inspecting the expected profit figures and seeing that maybe my order quantity, the optimal value is going to lie between 20 and 39. If that is the case, then I don't want to do extra or excess work unnecessarily. So I'm going to just take this window or range of my order quantity. Good. So what I do is I copy this value down. Okay. So I copy this down. There we are. We get the profit figures. Okay. And I then copy this. I do a Control C, and I'm going to, I'm going to just cover the entire range of order quantities till 39. Okay, and then I'm going to press enter, and there we are. We have got the full range of profit values. Okay, please note, we have got the full range of profit values for the entire range of order quantities. Interesting. Just one formula, and we are done. What next? Now what we do is we come to the bottom here. What are we saying using this Excel? Now please look at or please consider the order quantity 20,000 units. The order quantity 20,000 units has got a number of possible profit figures. Each profit figure has got a certain probability. Remember, the profit figure came from the demand figure, and the demand has a certain probability, and therefore each of the profit figures has got the respective probability of occurrence, and I want to find out the expected profit for the entire range of demand. All I need to do is multiply each profit with the respective probability and sum. Okay, so that is going to give me the expected profit for that quantity Q. Very simply, we use the inbuilt function sum product. Okay, and sum product of what? The probability column. Okay, so I cover the entire range of the probabilities. Okay, and then I choose the profit column under 20,000. So there we are. I close the bracket. Now there you can see at the bottom our formula that we are using. Now please, once again, because we are going to drag this formula horizontally to cover all different values of Q, the profit columns will keep changing, so I don't need any protection there. But I do need a protection for our probability column. I don't want the probability column to change as we drag the formula to the right. And to protect the probability column, which is column C, I'm going to simply add a dollar sign here. So dollar C6 till C40. Okay, so I hope this is also clear. So I press enter, I get a expected profit value, and what I do, of course, is that I drag this to the right as I had mentioned earlier, and there we are. I have got various expected profit values. Now I don't need decimal places, so let me just get rid of the decimal places here. There you are. So let me also highlight this with a yellow. So we have our profit figures, expected profit figures at the bottom under each order quantity. Now interestingly, what we can do is, just to show you, by the way, even by inspection, let us see. Where are we getting the expected profit figure as maximum? 325, 326, 327, 327, 852, and then 327, 218. Now please note that the profit figure was, expected profit was increasing all along, and then we reach 327, 852. Okay, and then we have 327, 218, and 326, and so on. So it looks like that the maximum of the expected profit happens to be this one, which is for an order quantity of 34,000. Now just to be clear, let me also draw a graph. So what I'm going to do is, I'm going to hide the columns, the rows. There you are. I'm going to hide all the rows so that we only have the order quantity and the the respective profit figures, and if I were to do a scatter plot, perhaps, let me try this out. Insert a scatter plot. Let me choose this one. I don't know what we will get. Oh, I made a mistake. I'm very sorry. I should have changed the sequence. So we have deleted that. Let's do one thing. Let me copy the quantities here. Control C. Take it to the next page, and perhaps do a paste special. Here I do a transpose so that I get all the order quantities here, and then let me also take the profit figures, do a Control C, copy, and then I don't know. Let me try transpose. I'm not sure whether this is going to come or not. Oh, no, it didn't. So let me paste this as values first. Yeah, and then copy this one and transpose it here. Paste special, transpose. Yeah, so this is what I want, and then I select these two. So I have order quantity and the respective expected profits, and once again we choose our graph. So let me get rid of this legend. So there you are. If I were to expand this, perhaps, now this is something interesting. Let me explain this graph. Okay, what we have done is, we have the profit figures along the y-axis, and we have the order quantity along the horizontal x-axis. And ideally the graph would have been something like this, almost like a parabola, but we see only a part of that parabolic graph, because our order quantity started at 20,000. Now we could have started at 10,000 or even 5,000. Calculation is calculation. We could have used the Excel to do all our calculation. We would then have got a much longer or a much spread out view of that parabola, but really it is not important, because what we are more interested in is the top point of this parabola, which gives us the maximum value of the profit or the expected profit, and that top point, the maxima corresponds to a value of about 34,000 units. Okay, so I just wanted to visually show you, how we get that optimal order quantity, and I can now safely get back to our, so there you are. We are back to our PowerPoint. This is the sequence in which we went. I want to just recap this. We take the entire range of demand from 0 till mu plus 3 sigma. We discretize that demand so that we get discrete values of demand with the corresponding probability. The probability of each discrete demand is calculated using this cumulative probability function. Okay, and then what did we do? We considered a range of order quantities. In our case, we started at 20,000, ended at 39,000, and the gap or the increment was 1,000 units. For each value of the order quantity Q, we calculated the profit for the entire range of the discrete demands for that column. Okay, we used our usual formula, and that was revenue minus cost. After we got all our profit figures for the entire range of Q values, we calculated the expected profit under each Q, and then of course we selected the Q that maximized the expected profit figure for us. And in our example, with the given data, that maximum order quantity was 34,000 units. So this gives us a kind of a review of what we did on the Excel. You can follow this. Sorry, to kind of recap, whatever we did. And in any case, so this Excel file will be placed on Moodle for your reference, so you can open the Excel file and actually go through it. This gives a bigger picture with the expected profit numbers at the bottom, and so on. And like I said, this quantity 34,000 maximizes the expected profit. There you are. I know this might have been a little involving session in the sense that it involved a lot of number crunching, but frankly speaking, it's very simple. If you try doing it yourself for any other demand distribution, or not any other demand, normal distribution, but with some other values of mean and standard deviation, or with the same thing, you can redo it on your own. You will find far more comfort, and familiarity with whatever we have done. Now, before I end this session, there is a question that might be creeping in your head, and that question is that isn't this method too long, too exhaustive? Every time we have to find out the optimal order quantity, do we really have to do all of that number crunching? Just imagine the poor retailer who is going to actually order for an item which is perishable. Forget about Reebok. Reebok might have a number of computers and technology to aid in the calculations, but the poor retailer, the roadside vendor who is going to order for let's say bananas that the retailer wants to sell on the roadside. Remember, bananas are perishable, or this particular model is very popularly known as the news vendor model. News vendor, because imagine what happens to the news vendor. News vendors are those people who buy newspapers in bulk early in the morning on a day, and then sell those newspapers throughout the day, and the next day, whatever inventory they have left with, at the end of the previous day, that inventory is gone. They don't get any return for that inventory. So perfect example of a single period inventory model. So imagine these kind of sellers or retailers or vendors, they don't have Excel and spreadsheets and all of that to do such long calculations. And so do we have a better, simpler, much shorter method to arrive at the same answer? Fortunately, we do. And that brings us to the analytical method for solving the same problem. And that is what we will consider in the next module. Goodbye.